Welcome to Anne Arundel Mechatronics Introduction to Robotics. This is for Lab 6. And in Lab 6, we're still going to be using the Arduino board. But we're also going to get familiar with some motors like the servo motor and DC motor. And for that, we're going to use this Arduino shield that it would allow us to connect the motors easily to these pins here. Then we have also other input devices that we can connect, and analog devices and some LCD connectors. This one also will allow us to provide a little bit more power, because the motors are going to need more than just 5 volts what the Arduino can provide. So we're going to be using like a 7.2 volt battery, rechargeable battery. And then the servo motor is very widely used for robots to move their arms, legs, sometimes to steer wheels, because the shaft of the servo motor, it can move from 0 degrees to 180 degrees. In Objective 1, you're going to see how we can program it so this shaft moves to each degree that we want. And you can also tell it's a servo motor because it has 3 wires, black, orange, and white. Sometimes this orange could be yellow or red. And then you have the DC motor that obviously is going to give us a little more power if we want to move gears and the wheels. Instead of steering them, they will move actually the shaft for the wheels. So let's take a look at Objective 1, and that is with our servo motor. Let's take a look at the sketch for Lab 6, Objective 1. The word include is a directive that would add the servo.h library file to this program. Servo.h library, it has any code that we would need to be able to communicate between the motor and the Arduino board. Next, we need to create a variable name, which is in this case servo motor -1, and that is going to be the variable name for the motor. On the void setup, I'm using attach, this function attach. It assigns or allocates a pin number, and in my case is number 10. Then in the void loop, I'm giving the servo motor -1 instructions. They're all pretty well the same, but it's just changing the degree for their shaft. So each value that I'm using here are the degrees that I want the shaft to move. Now let's take a look at the actual servo motor and the Arduino board that has it is connected. So I created this ruler, that way you can see how each instruction that I given, like the 45 degrees, that's the starting point right now, and then 0 degrees, and it should move from 0 to 90, then to 135, and 180, and back to 90, and then the loop starts all over again. So let's fire it up and see how it works. As the cycle starts. And that concludes this lab. Thanks for watching. So now we're going to talk about Objective 2 for Lab 6. It's basically the same as the objective 1, but this time we're going to be using a potentiometer to change the angle of the shaft of the servo motor. So we still have the include to be able to communicate with the servo motor through the Arduino board. I have not changed the variable of the motor, but I've included the a variable for the pot, and this one is because it's an analog, is going to be communicating through pin number 0. And then I have another variable that we're going to use later for in the loop void. So in here I included the serial monitor because then I like to demonstrate how as we move the pot settings it will change the value that is going to use for the servo motor. Then the void loop, we have where the value of the pot is going to be read by this function analog read on pin number 0. That value is going to be mapped to be able to use it for the servo motor. So the pot values can be from 0 to 1023, but the values for the servo motor can only be from 0 to 180 degrees. This map is going to change any values from the analog read between 0 and 1023 to average to between 0 and 180. So let's see how this works, and then I'll demonstrate how the map is working. Let's take a look at the circuit itself. So as you can see, here's my pot. I just created a little arrow so that you can actually see how it actually gradually moves. And here's my servo motor connected to the Arduino board and the Arduino shield and powered by a battery. So as this part here is actually 180 degrees. So as I move the pot, as you can see, the shaft of the servo motor is also moving. And that's about a 90-degree angle. Now, once it starts to move towards a 0 degree, I'm not sure if the pot has an issue, but the pot needs to move further in there. I think there's something wrong here, but as you can see, the values have been transferred to the motor, and the motor shaft is turning depending on how the voltage that I'm providing, the value that I'm providing. Voltage is also the value that I'm providing through the pot. So let's take a look at how the serial motor works for this. Okay, so I brought the serial monitor up. You can see, let me click out of scroll. Of course the values are going to change, but if I stop it there, that is 180 degrees for the motor, but it's 120 for the pot value. So if I change it to the 90 degrees, the value now is almost 98 degrees, and the pot value is about half too of 1023. And the same thing with almost the pot. So that's how you can see. If you need to precisely know what value you need to where the motor needs to start, you can always use this to gauge that. So that concludes Objective 2 for Lab 6. So now that I have the serial monitor on the screen too, as you can see, okay, so that is about 180 degrees, and the pot value is 1023, and it, as you can see, it matches. So if I change this to about there, it should be 45 degrees or pretty close to that. I'm sorry, we were going the other way, so it would be 145. And then if I change it to there, it should be around 90 degrees, pretty close. And we move it all the way to the right, it should be getting close to 0 degrees for the, and then value 0 for the pot. And that concludes Objective 2 for Lab 6. Thank you for watching. So this is Lab 6, Objective 3. And the objective is that when we press a forward button or a reverse button, a DC motor is going to spin in that direction. But before I get to that, I'd like to explain a little bit more this sketch with instructions, because this motor here, as you can see, is actually a servo motor, but it will help me explain why I wrote the program the way I did. We can still use the servo.h library file to be able to communicate with a DC motor. So here's our DC motor. So, and then what I add, I declared the variable for the DC motor so we can communicate between the Arduino and the motor. Then I have two variables. The reverse button is this one here that is attached to pin number 7. It's hard to tell, but it's number 7. And then the forward button, this one here, is attached also here to pin number 4. And the communication from those pins is digital, so that means that we're going to have highs and lows. This time I'm introducing the pull-up command or function. This is to activate the internal pull-up resistor, the Arduino board. Because of the DC motor, it actually draws a lot of current, and it also needs the additional battery for source, so it could burn the Arduino board. So the pull-up resistor is internal within the Arduino, and we're gonna, this pull-up command enables it. We have again attached number 10, that's the pin for where the DC motor is going to be. And then in the loop, the void loop, here's where it gets interesting, because as you can see, I wrote 45. So 45 on the server type of command, that will mean 45 degrees. Okay. Or 20. It could be 45 or 20. That's pretty close. So what happens is that the when the reverse state, meaning the reverse button, it is low, I have pressed it, and the forward is high, so I'm not pressing it. that means the shaft is going to move 45 degrees. There you go, 45 degrees. And if I press the forward, it's going to move it to 135 degrees. And that's because the servo motor can only rotate 180 degrees. Now, the difference with the DC motor is it can rotate 360 degrees. So what we're doing is creating an illusion here, because let me change the motors now. The illusion is because it's gonna look like it keeps spinning and spinning and spinning, but in reality it's moving 45 degrees every single time in one direction, the 45 degrees that it would be for the servo motor. And the same thing with 135 degrees, it's gonna keep moving this way, but it just doesn't stop. So it creates the illusion that it's going reverse or it's going forward. So let's take a look at how that happens. Number pin 10. So if I press that button, maybe it's not plugged in. Make sure it's pin number 10. Yeah. Okay, so there's some loose wires. So you have press reverse. It's going to move it 45 degrees infinite times, so it makes it look like it's going reverse. If I press the forward button, it's moving it 135 degrees infinite times, so it has the illusion that it's moving forward. Now if I was to press both buttons, it would move. If you don't press anything, it doesn't move. And that concludes Objective 3 for Lab 6. Thanks for watching. Hello again. So we have now we still have the DC motor, but now we have a start button and a stop button. We're using the Arduino board and a battery pack to power up the DC motor. The objective of this is that when I press the start button, the motor will just spin and spin and spin and spin until I press the stop button, like an emergency button. So let's take a look at the sketch very quickly. We're still using the servo h.h library file. We got a variable for the motor. Our start button is still using pretty well the same pins as before from Objective 3. And now, nothing much has changed. The only thing has changed is the code in the loop. And some suggestions were to use a while statement. But it was very hard to break a while statement because this is already in a loop. So I decided to go with very simple, if the start state for the button is low, then just keep on spinning. But if the stop state for the stop button goes low, then it stopped the motor. And because it's already in a loop, it's just going to keep on running and running until I press the stop button. So I don't have to put my start state in a while loop. So let's give it a try. I press the start button. And the motor starts running. And as soon as I press the stop button, it stops. I can have the stop button pressed, and if I press the start button, it won't go. Or I can press the start button while it's pressed and press the stop, and it will still stop the motor. So this is a fun lab, and that concludes Objective 4 for Lab 6. Thank you so much for watching, and keep safe.